Good morning. So today we're going to finish, it's our last day of review. We're going to talk about rules of exponents. So remember, we have a bunch of rules. So when we multiply like bases, we are going to add the exponents. Okay, when we raise a base to a power, we are going to multiply those exponents. When we divide like bases, we are going to subtract the exponents. When we raise a base to the 0, it is going to be 1, and then when we have a negative exponent, we can make it positive by moving it to the denominator. Okay, let's do some examples. So, if I wanted to raise this to the third power, then that would be 3 cubed times x to the 6th, y to the 6th. So 3 cubed is going to be a 27, x to the 6th, y to the 6th. Okay, if I wanted to simplify here, okay, to simplify the numerator, simplify the denominator, and then do the division. So this is going to be a negative 3 squared, x to the 6th times 2, which is an x to the 12th. Multiply here, so 5 times 3 gives you 15, and x to the 3rd times x to the 3rd is x to the 6th power there. So a negative 3 squared is going to be a positive 9. And then now I need to simplify. So 9 divided by 15 can reduce. 3 can go into both of those, so we're going to be left with a 3 over 5. Okay, and then x to the 12th minus 6. So this is going to be a 3/5 x to the 6th power. Okay, so make sure you can remember your rules of exponents. Okay, simplifying polynomials, when you add, you just combine your like terms. Okay, when you multiply, everything in the first one gets multiplied by everything in the second one. Okay. Okay, if I wanted to subtract my polynomials, then I need to distribute that negative sign. So it's going to be a negative 2x squared, and negative times a negative 4x is going to turn into a positive 4x. Okay, so combine your like terms. So x squared minus a 2x squared is a negative x squared. 4x plus a 4x is a 8x, and then minus a 2. Okay, so simplifying polynomials, we combine our like terms. When we multiply our polynomials, everything in the first one gets multiplied by everything in the second one. Okay, so x times x gives me a x squared, x times 9 gives me a 9x, 4 times x gives me a 4x, and then 4 times 9 gives me a 36. Combine your like terms. So x squared plus a 13x plus a 36. Alright, when we say x minus 5 squared, that's the same thing as saying x minus 5 times x minus 5. So we need to multiply that out. So we'll get x squared minus a 5x minus a 5x plus a 25. So x squared minus a 10x plus a 25. Okay, when you want to divide polynomials by a binomial, okay, so if we wanted to divide a polynomial by a binomial, we're going to separate. Each one is going to be put over that binomial. Okay, so 6 goes into 18 3 times. A cubed over a is an a squared. B over b goes away. 6 goes into 12 2 times. A squared over a is an a. B squared over b is a b. And 6ab over 6ab will leave me with a 1. Okay. Alright, simplifying rationals, or simplifying square roots. Okay. We need to remember our perfect squares. Okay. Our perfect squares: 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121. We could keep going forever here. 144, 169. Okay, so if I wanted to simplify the square root of 4, square root of 4 is just going to be a 2, right? Well, if I wanted to simplify square root of, let's say square root of 28. Square root of 28 is the square root of 4 times the square root of 7. So square root of 4 is a 2, and then whatever's left over is going to be still underneath that square root. The square root of x to the 4th. Square root of x to the 4th is x squared times x squared, right? So the square root of x to the 4th is just going to be a x squared. Okay, this is also like saying x to the 4th raised to the 1/2 power, because a square root is the same thing as a rational exponent. Okay. Cube roots, remember, okay, we have to have 3 of the same number underneath it before we can take one of them out. So the cube root of 40, okay, is going to be the cube root of 8 times the cube root of 5. Well, the cube root of 8 is 2, and then we'll be left with cube root of 5. Okay, cube root of 54. Okay, so that would be cube root of 27 times the cube root of 2. So the cube root of 27 is 3 times cube root of 2. Cube roots are a little bit more difficult to remember than your square roots. Okay? Okay, so I did one just a second ago, but if I take the square root of 9x to the 4th, so I would take the square root of 9, and I'm also going to take the square root of x to the 4th. So square root of 9 is going to be a 3, and then square root of x to the 4th is just going to be x squared. Okay, if I take the square root of 36x, square root of 36 times square root of x, so square root of 36 is a perfect square, so that's a 6, and you'll be left with the square root of x still underneath there. Alright, what about square root of 28, a squared, b squared? Well, we would take the square root of 28, take the square root of a squared, and then take the square root of b squared. Well, square root of 28, we did that just a second ago, would be 2 square root of 7. Square root of a squared is an a, and then the square root of b squared would be a b. So your final answer would be 2ab square root of 7. Okay, our next thing is going to be factoring. So remember, the first thing that you always look for is a greatest common factor. The second thing you look for is how many terms you have. Okay, if you have 2 terms, then you're going to hope that it's going to be the difference of 2 squares. If it's a difference of 2 squares, then it can factor to one that's minus and then one that is a plus. Okay, if you have 4 terms, you're going to factor by grouping. And then 3 terms, you're going to have 2 different ways. You're going to have a basic one, okay, where we have we see what multiplies together to be a c and adds together to be a b. And then we have our ax squared plus bx plus a c, where we figure out what multiplies together to be ac and adds to be a b. Okay? And then you factor by grouping. Let's try some. Okay, so if I wanted to factor here, I always look for a greatest common factor. Here I've got an x in common. So if I could take out an x, I'll be left with xy plus an 8. Remember, you can multiply it back, and it should always give you what you started with. Okay. Okay, if I wanted to factor here, there is no greatest common factor, but there are 2 terms. There's a minus sign in the middle. My first term is a square, my second term is a square. So that means that that's going to factor to 2m, and 9n, and a 9n. One's going to be a minus, and one is going to be a plus. Okay. Here we're going to, is there a greatest common factor? There's no greatest common factor. So then I'm going to ask myself what multiplies together to give me a 30 and adds together to give me a negative 13. Okay, so what multiplies together to give me 30 positive? So it's going to have to be a negative 10 times a negative 3, because a negative 10 minus a 3 adds together to give me a negative 13. So this is going to be able to factor to x minus 10 times x minus a 3. Okay. Alright, what about this one? 3x squared plus a 10x plus a 3. Is there a greatest common factor? No. So I'm going to ask myself, 30 times 3, so something has to multiply together to give me a 9, and at the same time add together to give me a 10. So that is going to be 9 times 1, and 9 plus a 1. So here's going to be a difference, because we have a 3x squared. We're going to separate the middle term, and it's going to be the 2 terms that you found, okay, with an x attached to them. so that's all we're doing is separating that. Okay, there are 4 terms here, so we're going to factor by grouping. Out of the first one, we can factor out a 3x, and I'll be left with an x plus a 3. Out of the second one, I can factor out a 1, and I'll be left with x plus a 3. Your parentheses are the same, so you're going to be left with x plus a 3 times 3x plus a 1. Multiplied to see if that's what you started with. Okay, also remember that if you can't factor a polynomial, then it is prime. Okay? Dividing a polynomial by a binomial. Remember, you're going to factor. This should all be fresh on your mind, what we just did. So you're going to factor and figure out what's common in the top and common in the bottom. So x squared minus a 12x plus a 20 all over x minus a 10. So I'm going to factor my numerator. So I asked myself what multiplies together to give me a 20 and adds together to give me a negative 12. So it's going to be a negative 10 times a negative 2, and negative 10 minus a 2 would give you that negative 12. So this is going to factor to x minus 10 times x minus 2. And this is all going to be over x minus 10. Well, I've got an x minus 10 in the numerator and an x minus 10 in the denominator. So, final answer, I'm going to be left with an x minus a 2. Okay? Now this should all be but when you're looking at a quadratic, okay, the standard form is ax squared plus bx plus a c. So we want to find the vertex. Remember, the vertex is negative b over 2a, and then the function evaluated at negative b over 2a. Okay, remember the axis of symmetry. Okay, it's just going to be the x part of the vertex, so it's negative b over 2a. Okay, quadratic formula is always a parabola, so it's going to open up or it's going to open down. If the a here, if the a is a positive, okay, if it's an a, then it's going to open up. If it's a negative, it's going to open down. Okay, when you solve a quadratic equation, you're finding the x-intercepts. So, when solving, you will find x-intercepts. Okay. So if you wanted to solve here, make sure it's equal to 0. You can factor out an x, and then you set both of your factors equal to 0. So x will be equal to 0, and x plus 8 will be equal to 0. So these are the two values where it's going to cross the x-axis, at 0 and at negative 8. Okay. Alright, so it needs to be equal to a 0. So I need to say x squared minus x minus 2 is equal to 0. So now something has to multiply together to give me a negative 12. At the same time add together to give me a negative 1x. Okay, so it's going to be a negative 4 and a 3. Okay, there's a 6 in the front, so that means that my middle term here is going to be separated by negative 4x plus a 3x. Group. Out of the first grouping, I can factor out a 2x. I'll be left with 3x minus a 2. Out of the second grouping, I can factor out a 1. I'll be left with 3x minus a 2. Now your parentheses are the same, so you'll be left with 3x minus a 2. And inside there, you'll have a 2x plus a 1. Set both of those equal to 0. So we'll have 3x is equal to 2. So x is going to be equal to a 2/3. And over here, x is going to be equal to a negative 1/2. Okay. Alright, I think that's it. Remember, there are some word problems associated with quadratics. Okay, so just remember, same thing, we set them up, set them equal to 0, and solve. Alright, y'all have a great, great day.